In this problem, you've been told lots of things. Everything means something. Continuous on the open interval from 1 to 9. Open means that the endpoints are open, not closed. Continuous means that we couldn't have either an asymptote or a hole. So we can't have any of those things. Then it says at x equals 3, there's a critical point. Critical point means the derivative is 0 or undefined. And then there's another critical point, and it is differentiable at that critical point. Then it says there's exactly one relative max and one relative min, and that exactly piece is important. We could have something like this. Exactly one max, relative max, and one relative min. But we need to have a cusp somewhere to deal with the fact that at x equals 3, we're not differentiable. So I could change my picture here like this. Now I have a max, and it's also a cusp if I label this x equals 3. The last piece, neither an absolute min nor an absolute max exist. And so now it all depends where I put my endpoints. If I put my endpoints in the right place, I can satisfy this. Here would be an indication of a max, a min. But here we have an absolute min, and we also have an absolute max. But instead, if I took this endpoint and put it higher than the absolute max, now this is just a relative max, and there's no absolute max because I approach but never reach this endpoint. Similarly, I would need to drop this one down below my relative min, and now I've satisfied everything. There's lots of possibilities that work, but this is one of them. We have a critical point that's a relative max, and there's exactly one relative max. There's a relative min, exactly 1. This is a critical point where we're differentiable, nice and 0 slope down there, and we have no relative max or min. No absolute max or min because of these open intervals.